Hi, this is 6.1. We're going to look at a couple of big ideas from this section. The first is rational exponents. I'm talking about exponents like this, 1/2, 1/3, any fraction. And we have defined those to essentially mean the roots. So this first one is a square root that can be rewritten as 3x minus 2 to the 1/2. Here we have a cube root, the cube root of 4x squared minus 5x. That can be rewritten as 4x squared minus 5x to the 1/3. The general idea is if you have any number, let's call it a, to the m divided by n, the numerator is your power. So it is a to the m. The denominator of that fraction is your root. And so it is the nth root. Hence why you would say the square root of 64 is 64 power of 1 over root 2. It kind of simplifies and really does us a lot of favors when we are trying to manipulate radicals with exponents. So let's take a look at a couple of ways that this will come up. The first of which is just to simplify a exponential and a radical. So here we have the quantity x plus 1 cubed, and then the square root of that. And again, remember when there is nothing written right here, there is an implied 2. And so therefore we know that that is a square root. So I would rewrite this simply with a rational exponent as x plus 1 all to the 3 is my exponent, 2 is my root. So 3 over 2. Here's another situation where a lot of times it's easier, instead of dealing with a fraction or a quotient, we would want to convert this. Now I would say, all right, this is going to be 1 over the quantity 2x minus 1 to the 1/2. And we can take that one step further. We know that if it's in the denominator, if you move it to the numerator, you're going to change the sign of your exponent. So we can simplify this to 2x minus 1 to the negative 1/2. And for some applications, in calculus and things like that, this form is a lot easier to work with rather than trying to manipulate a fraction. So it just kind of avoids that for us. Other times, you may see a number like this where we are maybe going to try to evaluate this. And so what do we need to do? Well, you can really do this two different ways, kind of two different offshoots here. The first is you could take 16 to the third, and then you could try to do the square root. Now, I don't know what 16 to the third is, so that doesn't seem like a very good plan. The other way that you can do this is you can evaluate the root first. So you can do the 16 to the 1/2, and then you can do the 3. And remember, power over power still applies here. If you were to multiply these two things, 3 times a half is 3/2. The bottom one is easier though because I do know what the square root of 16 is, or 16 to the 1/2. 16 to the 1/2 is 4, and then we've got 4 to the third, which then is 4 times 4 is 16, and another multiplied by 4 is 64. So you can have expressions, numbers, variables, anything you really want underneath a root, and you can have anything you want underneath a rational exponent. Things, of course, you do need to worry about is domain, and we'll talk a lot about domain in this chapter. If we have x to the 1/2, remember that that means the square root of x, and in this situation, the domain would be all numbers greater than or equal to 0. Remember, we cannot have a negative number underneath a square root, or really any root that is even. So square root, fourth root, things like that. Rational exponents are helpful when we are trying to solve. Most of the time, whenever we're trying to get rid of a power, you would use a root. Well, sometimes it's easier to think of it as a rational exponent. So we'll focus on this first question. We're asked to solve. We're going to isolate. So the first thing you would do is divide both sides by 4. Gets you x to the 5th is equal to 128 divided by 4 is 32. Now at this point, if you can figure out what to the 5th is 2, then you're going to be fine. But the other way that you can do this on your calculator is to take a 5th root of both sides, or an exponent of 1/5. We're going to use the multiplication property here, or power of a power. We multiply. 5 times 1/5 is just 5, or it's just 5 over 5, which is just 1. And then you can type into your calculator 32 to the 1/5. You'll find that to be 2. You do want to recall, though, that if this is an even exponent, just like when you take a square root, plus or minus, since this is odd, we don't need to worry about the plus or minus. The answer has to be positive 2. The answer of negative 2 is not a solution. That would yield us a negative 32. Next example, similar situation, we need to isolate first. So we've got x to the 3/2. Minus 10 is equal to 115, so I'm going to add 10 to both sides just to isolate this variable. And that's 125 over here. And your plan after this is basically a reciprocal, and that's kind of what we did on the previous example as well. The reciprocal of 5 was 1 over 5. The reciprocal here is going to be 2/3. We're going to use a reciprocal because power of a power says when you multiply, you're going to multiply your powers here, power of a power. When you multiply 3/2 times 2/3, you end up with x. And over on the other side, 125 to the, in your calculator, you would multiply that out, and the answer is 25. Now we do want to stop and think, do I need a plus minus here? So is it also x equals negative 25? And there's really no exact science on how and what you need to do first. So we have a 3/2. I'm going to go back to this original equation right here. We have a 3/2 there. So do you do the power to the 3rd, or do you do the square root first? Well, in this situation, actually it doesn't matter, because no matter what, if you were to put a negative 25 in for x here, okay, if I were just to take a negative 25, and if we were to take the square root first, if we were to do the 2 first, we would have an undefined answer there. There is no square root of negative 25. So that causes a problem. If we did the 3 first, we would have negative 25 to the 3rd. That's going to be negative, it's a negative number. Okay? And so even though we've taken that power, now when you evaluate it, the square root, it still is going to blow up and you're not going to be able to solve it. So negative 25 is not a solution. It's just 25 that we need. Last example here, you've got an x minus 4 to the 1/3 quantity, and we want that to equal 7. So again, the same thing here. We're going to do the reciprocal. Reciprocal of 1/3 is 3. Those things multiply together to make 1 right there, power of a power. So you're just left with x minus 4 is equal to 7 to the 3rd is 343. Add 4 to both sides. X equals 347. It's always good to check your answers so you can just kind of plug it back in, take a look. If I put 347 up here, will it work? Well, subtract 4, you get back to that 343, and you take the cube root of that, or the 1/3, and you get 7. Your homework assignment is posted on Schoology. and are these problems.